This lesson is going to review how to perform operations with radicals on the ACT exam. I will show you how to simplify radicals as well as how to add, subtract, multiply, and divide them. Now let's return to the classroom for this lesson. Okay, let's talk about operations with radicals. But before we can do anything, we need to know how to simplify radicals, such as the square root of 12. You need to be able to write that as a product of two numbers, one which is one of those perfect squares, such as 4 times 3 is 12. Now, one of the rules of radicals is when you're multiplying or dividing, you can break it into two separate radicals, so it looks like this. Square root of 4 times square root of 3. Square root of 4 is 2, so we'll write it as 2 radical 3. Or 2 times the square root of 3. Now that's one way to do it, and that can take some time. And you don't have a lot of time on the ACT, so you've got to be able to do it faster. So let me show you how I would do it. Let's take another radical, like 75. Whenever you have a multiple of 25, 25 is a perfect square. If you have 50, 75, 125, those are multiples of 25. I would use 25 times something. So 25 times 3 is 75. What I do is write the 25 times 3 above the radical and write the perfect square first. That's the 25. Take the square root of 25, that's 5. And 3 cannot be simplified any further, so you can just leave it 5 radical 3. All right, let's try one more, and then we're going to go ahead and add some variables to it now. Square root of 98. Now, you have to think about what times what is 98. One of those numbers is a perfect square. 49 times 2 would be the numbers to use. Square root of 49 is 7. So you get 7 radical 2. Now let's talk about how to handle when you have variables involved. You have to recall the square root of x can be written as a power, x to the 1/2. So if you would have had x to the, I don't know, we'll do 7. You're going to ask yourself, how many times will 2 go into 7? And that would be 3 times with 1 left over. So that's how you handle it with variables. Now let's add the numbers and variables all together now. Such as the square root of 288, x to the 5th, y to the 6th, and z to the 7th. Okay, you're going to have to think about, well, what times what's 288? One of them is a perfect square. That would be 144 times 2. Square root of 144 is 12. Leave yourself a little space because you're going to be putting some x, y, and z's here, so leave a space for like 3 variables. Put your square root of your radical there, and then you have still the 2 inside. Now let's do each variable separately. 2 goes into 5 twice with 1x left over and 1x left over inside. Now 2 goes into the 6, the power of 6 on the y, 3 times. So you get y cubed on the outside, no y's left over in the inside. Now the z, we kind of did that with the x to the 7th. 2 goes into 7 3 times with 1 left over. So you'll have 1z left over in the radical. Okay, now let's talk about how to add and subtract radicals. Adding and subtracting radicals is kind of like combining like terms. If you would have 2x plus 3y, you cannot add those guys because they have different variables. But if you would had 2x plus 3x, you can combine those and that would give you 5x. Notice the x stays x. It doesn't become x squared. It's just like you had 2 apples and 3 apples, you have 5 apples. The same thing is with radicals. Let me show you how it works with radicals. Say I had 2 radical 7 plus 3 radical 7. You're going to add the numbers out front. 2 and 3, giving you 5. Radical 7. The radical 7 stays radical 7. Okay, well, let's try another one. A little tougher now. How about radical 20 plus radical 80? Well, you're saying, well, we can't add those. That's got to be simplified. No, we have to remember what we were talking about earlier when we were talking about simplifying radicals. What times what's 20? One of those numbers is a perfect square. That would be 4 and 5. Square root of 4 is 2, so you get 2 radical 5. And then 80, that's 16 times 5. Square root of 16 is 4, so we get 4 radical 5. Now you notice they both have the same radical, radical 5. So we just add the numbers 2 and 4, and we get 6 radical 5 out of it. Okay, let's try a subtraction one. Say we have the square root of 242 minus 3 radical 8. And if I say radical, I mean square root. So first one, we're going to look at square root of 242 and 8. Those aren't the same radicals, but we need to simplify them before we can try and subtract them. 242, I know 2 goes into it, and that would be 121 times. So 121 times 2, and 121 is a perfect square. That's 11. So you're going to get 11 radical 2. And with the 8, you can write that as 4 times 2. Now, this one's a little tricky. I wanted to add a little spice to this one to make sure you know how to handle it. Square root of 4 is 2. You're going to take the 2 times that negative 3. That gives you negative 6 square root of 2. And I want you to be able to do that because the ACT, it's all about speed and getting these done quickly and accurately. But if that's too much for you, you can do it in 2 steps. You can write it out. But we're ready to simplify it now. So you got 11 radical 2 minus 6 radical 2. And that's 5 radical 2.